Okay, finite math. This is section 2.5. This is a continuation of 2.4, and in 2.4 I showed you how to find the inverse of a 2 by 2 matrix. And then by knowing the inverse, you can use the inverse method to solve the system. Well, in this section, we're going to do the same thing, but I'm going to find the inverse using a different method, and this is called the Gauss-Jordan method because it so resembles what we're doing when solving using Gauss-Jordan. So here's the thing. So let's say matrix A is 1, 2, negative 1, 3. So I'm going to create a matrix over here, and I'm going to just say 1, 2, negative 1, 3. And those are the same numbers I started with here. And then behind it, you'll recognize these. I'm going to put a 1 and a 0 and a 0 and a 1. And that's what we call the identity. We've talked about that before. So here's matrix A, and there's the identity. That's the first step. Now we're just going to use our Gaussian rules. And according to Gauss, we want to get a 1 here. We've got a 1, so I'm simply going to circle that. And that becomes my pivot. And once you have a pivot, you want to get a 0 below it. So top row is going to stay the same. To get a 0 here, I'm simply going to take row 1 plus row 2. So 1 plus negative 1 is 0. We knew we were going to get that. 2 plus 3 is 5. 1 plus 0 is 1, and 0 plus 1 is 1. All I did was add row 1 to row 2. So if you'll notice, I got the 1 and the 0 in that first column. And we go to the second column. Here's your diagonal. You want to get a 1 where the 5 is. Top row stays the same. And to get a 1 here, we're simply going to take 1/5 row 2. So 1/5 of 0 is 0. 1/5 of 5 is 1. That's going to be my pivot, so I circle that. 1/5 of 1 is 1/5, and 1/5 of 1 is 1/5. I've got 1, 0, 1. I want to get a 0 where the 2 is using that 1. So we're going to take negative 2 times row 2, add it to row 1. So negative 2 times 0 is 0, plus 1 is still 1. I told you they wouldn't change once you got the 1s and the 0s. Negative 2 times 1 is negative 2, plus positive 2 is 0. Negative 2 times 1/5 is negative 2/5. Think of that as 5/5. So you got a negative 2/5 and a positive 5/5. This number is going to be 3/5. And then negative 2 times 1/5 is negative 2/5, plus 0 is negative 2/5. And the bottom row stays the same. Now, take a look at what happened here. When I started out, I started with this 1, 2, negative 1, 3. So matrix A was on the left, and the identity was on the right. Now look what we got down here. Where's the identity? It's right here. It's on the left. It started on the right, and somehow we transformed it to the left. And once we have the identity here, guess what this is? That's going to be the inverse. So the inverse will be equal to, all I got to do is copy these numbers. I know I'm going back and forth, but I've got 3/5. My next number is going to be negative 2/5. Then I got 1/5 and 1/5, and those end up being on the bottom right here. And that's how you find the inverse. That's a 1/5 there. I kind of got into my lines. So your inverse is 3/5, negative 2/5, 1/5, and 1/5. Okay, let's do another one. My next example, I start with 3, 6, 2, and 5. So I'm going to go 3, 6, 2, and 5. All I did was copy the numbers. And then you put the identity right behind it. Now I want to get a 1 where the 3 is. So we know we're going to multiply by 1/3. So that's 1/3, row 1. 1/3 of 3 is 1. That's my pivot. I'll circle it. 1/3 of 6 is 2. 1/3 of 1 is 1/3. And 1/3 of 0 is 0. Bottom row stayed the same. Now that you got a 1 here, you want to get a 0 below it. Top row stays the same. To get a 0 here, I'm going to multiply by -2. That's -2 times row 1 plus row 2. So -2 times 1 is -2 plus +2 is 0. We knew we were going to get that. -2 times 2 is -4. -4 plus 5 is 1. That's nice. Not only do we get a 0, we got a 1 there. That would be my next step. -2 times 1/3 is -2/3 plus 0 is -2/3. And -2 times 0 is 0 plus 1 is 1. And that becomes my next pivot. So I got a 1, a 0, and then automatically got a 1 there. That was nice. So the last step, you want to get a 0 here. So to get a 0 where the 2 is, I'm going to multiply by -2. So it's -2 times row 2, add it to row 1. So -2 times 0 is 0, plus 1 is 1. That didn't change. -2 times 1 is -2, plus the 2 up there, there's your 0. That's what we're trying to get. -2 times -2/3, that's 4/3. 4/3 plus 1/3 is 5/3. And -2 times 1 is -2. -2 plus 0 is -2. And the bottom stayed the same. So at this point, you'll notice you have the identity on the left, which means the inverse is on the right. I'm going to put it down here. The inverse will be equal to 5/3, -2, -2/3, and 1. Now, one of the questions you'll eventually ask, and I'm going to go ahead and answer it now, is can we use either method for finding the inverse? Because I showed you the other method in 2.4. Now it's 2.5, and I'm showing this Gauss-Jordan method. And for some of you, I know this is going to be more confusing. Well, okay, so when you're talking about 2x2 matrices, I don't care what you use to get the answer. If this is a normal testing situation where we're in class, then yeah, I'd probably make sure that you knew both of them, but I'm not going to be able to do that. You probably need to know both of them. And the real reason that we study the Gauss-Jordan for getting matrices is you can use this where it's a 2x2, 3x3, 4x4. I don't care how big it gets, it always works. The method I showed you in 2.4 only works for a 2x2. I rarely teach that anymore, but our book did it, so I went ahead and put it in here. Here's one more example. Let's work through this one. So we're going to start out with 2, 5, 1, 3. Forget my red circle there. 1, 0, 0, 1. That's the identity. So in the first step, all you're doing is filling in points. Okay, then we got to get a 1 up here. Remember, you can switch rows. And that's what I'm going to do, because if I multiply through by 1/2, I'm going to get fractions. By doing this, I stay away from fractions. So the second row comes first. So 1, 3, 0, 1. And the bottom becomes 2, 5, 1, 0. And there's your pivot. I want to get a 0 below it. Top row stays the same. To get a 0 here, I'm going to take -2 times row 1. I'm going to add it to row 2. So -2 times 1 is -2 plus +2 is 0. We knew that. -2 times 3 is -6. -6 plus 5 is -1. -2 times 0 is 0, plus 1 is 1. And -2 times 1 is -2, plus 0 is -2. First column is the way I want. I got a 1 and a 0. Now I want to get a 1 over here where I got -1. This will be easy. All I have to do is take the opposite of row 2. So the top row stays the same. And the bottom row, I'm just taking the opposite. So the opposite of 0 is 0. The opposite of -1 is 1. The opposite of +1 is -1. And the opposite of -2 is +2. And here is my next pivot. Okay, last step. Bottom row is exactly the way I want it, so I'm just going to copy those. I want to get a 0 where the 3 is, so I'm simply going to multiply by -3 times row 2, add it to row 1. So -3 times 0 is 0, plus 1 is 1. -3 times 1 is -3, plus +3 is 0. -3 times -1 is 3. 3 plus 0 is 3. And -3 times 2 is -6. -6 plus 1 is -5. So notice how I got the identity here? So my inverse is 3, -5, -1, 2. The nice thing about that, there's no fractions. Okay. So just as a quick review, if I wanted to solve this system here using the inverse method, I would think this is 1, 2, -1, 3, times my variable matrix, which is xy, equals 7, 8. Or if I want to find xy, I'm going to take the inverse of that matrix there. So I got A times X equals B. So down here, X will be equal to the inverse times B, which is 7, 8. So all I'd have to do is find the inverse of this one right here. If you go back to example 1, you notice how I have 1, 2, -1, 3. That's what I have here. So on here, I found the inverse to be, all I'm going to do is copy this. I don't know if you can see both of these or not, but I'm just going to copy this. I made this easy on myself. But 3/5, -2/5, 1/5, and 1/5. I already did that one, so I don't have to do it again. Okay, so now all we're going to do, we're going to take the rows of this one times the columns over here, and there's only one column. So X will be equal to 3/5 times 7 plus -2/5 times 8. I'll put parentheses around since it's negative. 3 times 7 is 21, so that's 21 over 5 plus, this is going to be -16 over 5. That ends up being 5 over 5, which is 1. So you know X is equal to 1. Okay, to find Y, I take the bottom numbers here, so that's 1/5 times 7 plus 1/5 times 8. So that becomes 7/5 plus 8/5 That's going to be 15 over 5, which is 3. So x is 1, y is 3. My answer is 1, comma 3. That part's exactly the same as 2, 4. The only difference was how I found the inverse. Okay. In a way, that was kind of a review of what we did the last time. So let's take it to the next level. Now I've got a 3 by 3 that I want to find the inverse of. So we know that we're going to go 2, 1, 1, 3, 2, 1, 2, 1, 2. And then you're going to put the identity behind it. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. First step, I got to get a 1 where the 2 is. So I'm going to take 1/5, row 1. So 1/2 of 2 is 1. That's going to be my pivot. 1/2 of 1 is 1/2. 1/2 of 1 is 1/2. 1/2 of 1 is 1/2. 1/2 of 0 is 0. And 1/2 of 0 is 0. And row 2 stays the same. And row 3 stays the same. So now that I've got the 1 here, I want to get zeros below it. So row 1 will stay the same, so I'm simply going to copy those. To get a 0 where the 3 is, I'm going to multiply by -3 times row 1, because that's where the pivot is, and I'm going to add it to row 2. So -3 times 1 is -3 plus +3 is 0. -3 times 1/2, that's -3/2. Think of that as 4/2, so -3 plus 4 is going to be 1/2. -3 times 1/2 is -3/2. Think of that as 2/2, so -3 and a +2 is -1, so it's going to be -1/2. -3 times 1/2 is -3/2 plus 0 is -3/2. -3 times 0 is 0 plus 1 is still 1, and -3 times 0 is 0 plus 0 is still 0. Now we go to the bottom row. We want to get a 0 here, so we're going to multiply by -2 and add. So it's -2. The pivot row is row 1. We're going to add that to row 3. I'm running out of ink. My favorite pen. I hope this will show up. Okay, so -2 times 1 is -2, plus +2 is 0. -2 times 1/2 is -1. -1 plus 1 is 0. -2 times 1/2 is -1. -1 plus 2 is 1. -2 times 1/2 is -1. -1 plus 0 is -1. -2 times 0 is 0, plus 0 is 0, and -2 times 0 is 0, plus 1 is 1. A lot of good things happen here. If you look at the bottom row, we're kind of done with that one. Okay. Now, think of your diagonal. We got a 1 here. Now we want to get a 1 here. We got a 1, 2 zeros. Now the 1's going to go here. Top row is going to stay the same. To get a 1 here, I'm simply going to multiply 2 times row 2. So 2 times 0 is 0. 2 times 1/2 is 1. That's going to be my pivot. 2 times -1/2 is -1. 2 times -3/2 is going to be -3. 2 times 1 is 2, and 2 times 0 is 0. And the bottom row stays the same. Okay, next step. I got the 1. The first column's done. Second column, I got the 1. Now I want to get a 0 here and a 0 here. I've already got the 0 there, so I don't have to worry about it. Just up here. To get a 0 on top, I'm going to take negative 1/2, row 2 plus row 1. So negative 1/2 times 0 is 0, plus 1 is still 1. Negative 1/2 times 1 is negative 1/2, plus positive 1/2 is 0. Negative 1/2 times negative 1 is positive 1/2. Positive 1/2 and another half is 2/2 or 1. That was nice. Negative 1/2 times negative 3 is 3/2. 3/2 and 1/2 is 4/2 or 2. Negative 1/2 times 2 is negative 1, plus 0 is negative 1. And negative 1/2 times 0 is 0, plus 0 is 0. Second row stays the same because that's where my pivot was. And then the bottom row, I want to get a 0 here, but I've already got it. That's nice. So all I'm going to do is copy the bottom. I don't have to do anything with that one. And when you look at the bottom, again, here's your diagonal. We want to get a 1 here, and we've already got it. That saved me another step. So this will be my last one. The bottom row is done. I'm just going to copy those numbers. And we're going to go up. To get a 0 where the negative 1 is, all I'm going to do is take row 3 plus row 2. So 0 plus 0 is 0. 0 plus 1 is 1. 1 and negative 1 is 0. Negative 1 and negative 3 is negative 4. 0 and 2 is 2. And 1 plus 0 is 1. Now we go to the top row. We want to get a 0 here using that 1. So we're going to take negative row 3 plus row 1. So negative 0 plus 1 is still 1. Negative 0 plus 0 is still 0. Negative 1 and positive 1 is 0. Take the opposite as 1. 1 plus 2 is 3. Negative 0 plus negative 1 is negative 1. And negative 1 plus 0 is negative 1. So now when we look at this, my inverse. See how you got the identity over here on the left? So on the right, I got 3, negative 1, negative 1, negative 4, 2, 1, negative 1, 0, 1. And that's my inverse. 3, negative 1, negative 1, negative 4, 2, 1, negative 1, 0, 1. Okay. Last example. I'm going to switch pens on this one. This will show up a little better. Okay, so now I want to take this system of equations. This is a 3x3 system. I hadn't done one of these. Everything I've done is 2x2. But we set it up the same way, using the inverse method. Okay, we're going to come up with matrix A, which is, it's just the coefficient. So I got a 2, 1, 1. 2, 1, 1. Next row is 3, 2, 1. And then 2, 1, 2. I take the coefficient matrix times my variable matrix, which in this case is X, Y, Z, equals, and my answer matrix, we'll call it B, is 1, 2, negative 1. That's those three numbers right there. Okay, so I want to know what X, Y, and Z are. That will be equal to the inverse times B. All I got to do is find the inverse of this thing here, which on the previous page just happened to be the same matrix. So down here, I found that inverse to be 3, negative 1, negative 1, negative 4, 2, 1, negative 1, 0, 1. All I'm going to do is take that and copy it right here. So I've got 3, negative 1, negative 1, negative 4, 2, 1, negative 1, 0, 1. Times matrix B, which is 1, 2, negative 1. Okay, so all I have to do, I'm going to have 3 rows over here. Times your 1 column here. So x will be equal to 3 times 1 plus negative 1 times 2 plus negative 1 times negative 1. So that's going to be 3 plus negative 2 plus 1. I believe that's going to be 2. Y, I'm going to have negative 4 times 1 plus 2 times 2 plus 1 times negative 1. So you got negative 4 plus negative 1. Those two drop out. I got negative 1. Okay, and then Z, I'm going to have negative 1 times 1 plus 0 times 2 plus 1 times negative 1. So it's going to be negative 1 plus 0 plus negative 1, and that's going to be negative 2. So if I did it right, my answer is going to be x is 2, y is negative 1, and z is negative 2. I'm checking my answers as I'm going through there. 6, 4, 4, 3. Yes, those are correct. So it's really the same technique we did for the 2x2s. I found the inverse of this one, and then you simply multiply. If you do all that, that gives you the answers. Okay, that ends section 2.5, and you should be set. I think that's the last one of this chapter. Okay, see you.